Today, we're going to explore a secret that's hidden in plain sight, the beautiful, underlying patterns of mathematics. You know, if you've always thought math was just about crunching numbers and solving for x, I really want you to hang on to this idea. This is the real heart of it all. Mathematics isn't just a tool for calculation, it's really a journey of discovery. It's a quest to find and understand the elegant patterns that make up our world. And the search, it's a deeply creative process. These patterns, they pop up everywhere, from the spiral of a galaxy to the veins in a leaf, even in the technology you're using to watch this right now. It's this incredible blend of logic and creativity that makes math both an art and a science.
Okay, so let's dive right in. And we're going to start with the most fundamental patterns of all, number sequences.
Now, you'll recognize some of these right away, of course, counting, odd numbers, even numbers. But look a little closer at the others. Squares, triangular numbers, cubes. Each one of these follows a simple, predictable rule, and this is really the foundation of looking for patterns.
So what happens when we take these abstract sequences and we make them visual? Let's see what these numbers actually look like. We're going to zero in on this one sequence right here, the squares. We saw it in the table a second ago, but there's a very good reason it has the name it does.
Now, this might seem like a really obvious question, but asking it is the key. Why give them a geometric name? What's the connection between the number itself and an actual shape?
And boom, the answer is just brilliantly simple. One dot, a 2x2 grid of 4 dots, a 3x3 grid of 9. The name isn't just some random label, it's a literal description. The number is the shape.
And get this is not just a one-off trick. The same beautiful logic applies to triangular numbers. 1, 3, 6, 10. Each one can be arranged into a perfect, elegant triangle. This is math you can literally see.
Okay, now this is where it gets really exciting. What happens when we see how these different patterns, these different sequences actually start to talk to each other?
Let's just do a little experiment. We're going to take that sequence of odd numbers, 1, 3, 5, 7, and we're just going to start adding them up one by one. What kind of pattern do you think is going to emerge?
All right, look at this. The first odd number is 1. Fine. Add the next one, 3, and you get 4. Add the next one, 5, and you get 9. Then 16. Wait a minute. Do you see it? 1, 4, 9, 16. The sums aren't just random numbers. They are the square numbers.
I mean, that's amazing, right? But it leads us to the single most important question in all of mathematics. Why? Is this just a crazy coincidence, or is it some kind of unbreakable rule of the universe? We need an explanation.
And once again, a simple picture gives us the answer. Just think of each odd number as an L shape. Now let's see how they fit together.
See that? Those 3 new dots form a perfect L shape that just wraps around the single dot to create a 2x2 square. And the next odd number, 5, it forms the next L shape, turning that 2x2 into a 3x3 square. It's not a coincidence, it's a beautiful geometric truth. This pattern will go on forever.
Now this whole search for patterns isn't just limited to numbers. It's just as powerful when we look at the world of shapes, the field of geometry.
I mean, just look at these basic regular polygons. A triangle, a square, a pentagon, a hexagon. The pattern here is super simple, right? It's just the number of sides. It's that basic counting sequence we started with. 3, 4, 5, 6. A shape pattern is linked directly to a number pattern.
But what if the rule we use is a little more interesting? Here we're going to start with a simple shape, a triangle. This is the first step in building something called a Koch snowflake.
Now for step 2, we apply one single, simple rule. Take every straight line and replace it with this 4-sided speed bump shape. And suddenly our simple triangle becomes this much more intricate, star-like object. And then we just do it again. We apply that same rule over and over to every new line segment. And the result is this incredibly complex and beautiful shape. A simple rule repeated creates infinite detail. This is the core idea behind fractals, shapes that are infinitely complex and look similar at any scale.
So let's bring all this together. We've seen patterns in numbers, patterns in shapes, and these beautiful connections between them. But what's the ultimate goal here?
We end up right back where we began, but hopefully with a much deeper appreciation for what this sentence really means. It's not just about finding the what, like, hey, adding odds makes squares. It's about discovering the why, seeing those elegant L shapes that explain it all. And this search for why,
Well, it's the engine of human progress. Understanding patterns in planetary motion is what gave us GPS. Understanding patterns in our DNA is how we cure diseases. Even the algorithm that recommended this to you is based on finding patterns. The search for these abstract patterns leads to very real-world breakthroughs.
So I'll leave you with this. The true secret of mathematics is that it's a way of seeing the world, a lens for spotting all the hidden connections and structures that are all around us. So, now that you know the secret, what patterns are you going to see tomorrow?